I'm going to look at questions 4 and 5 on quiz 10, and we're looking at the t-distribution. So just from the book, I just want to go over a couple things. The t-distribution looks very similar to the normal distribution. It works very similar to it, except it depends on the degrees of freedom. It depends on how many data points we have from the information. So we might have a sample of a population and we want to apply it to the larger population, but our sample is not that large. So we have to account for the degrees of freedom. We find the degrees of freedom by taking the number of points we have, subtracting 1. We subtract 1 because we lose 1 degree of freedom to calculate the mean. Calculating the mean is pretty straightforward. Is going to be the mean of x bar. The information we know is simply going to be the sum of x over n, just like you calculate the mean before. The sample standard deviation is going to be an estimation of x bar. So we have to be able to calculate the sample of a sample population, the standard deviation of a sample population. Once we have that, we can calculate this point of estimation by dividing by the square root of n. So similar to what you did in 8.1 and 8.2. And then we're looking for a confidence interval in that t-distribution, whatever it looks like, about some x bar. And if you go to the table in the back of the book, it looks like this. So it's symmetric, and so whatever percentage is shaded in to the right of t is also going to be shaded in to the left of minus t. So when we look at this confidence interval, if this was a confidence interval at 90%, this would make up 5%, and this would make up 5%. So we want a confidence area of 90%. We're looking for the t-value where it gives us 5%, so the 0.05 t-value. So it's a little bit different than the normal distribution, but hopefully that kind of makes sense there, what you're looking for. And we're going to see that in the very first example, question 4. Now I did some of this work already in Excel. I plugged in all these numbers in Excel, and I took the summations of the x and the summations of the x squared and followed the formula for the standard deviation of the random sample size. When I did that, I ended up with 9.815772. So Excel is very nice. The square root here. It's really easy to push a wrong button in your calculator. So it's really easy to push a wrong button in Excel. So you have to be really careful the way you go about that. So put those x values in. I take the summation of x squared minus the summation of x quantity squared over n divided by n minus 1, and then I take the square root of that. So I get that answer. I then find the estimation about our x mean, which is going to be s divided by square root of n. And in this case, square root of n is 34. Right? So if I plug that in my calculator, I end up with 1.683391. And that is going to be useful when I'm looking for this 90% confidence interval. Right? So I'm looking for an x bar plus or minus t times s bar, or sorry, s of x bar. So I know everything but t, and then t is found in the table. I have 34 participants, so my degrees of freedom is going to be 33. And I want 90% confidence interval. So if I look at the t-table, if I want a 90% confidence interval, this is going to be 0.05. This is going to be 0.05. So I'm looking for a t-value with a degree of freedom being 33. Degree of freedom being 33. So I come down here, go back up to the top, and I want my area to be 0.05. And so I get the t-value to end up being 53.12 as x bar. And that was calculated by just adding up all the x's and dividing by n, plus or minus the t-value, which we found to be 1.692 from the t-table, 1.692. And then I was given, or I calculated the 1.683391. And if you plug that in, you should get 50.27 to 55.97.